The arrival of the internet, mobile, and cloud computing followed a predictable cycle: excitement, uncertainty, and then adaptation. Engineers who thrived during those shifts leaned in early, made mistakes fast, and mastered the new rules before the terrain settled. Today, every engineering team is split into four camps. You have those who are ready to build immediately, those who are uncertain about their future value, those whose daily workflows have already shifted, and those who can see exactly how AI could solve problems they've stared at for years. The advantage belongs to the group that takes action. Because the technical barriers between a concept and a working prototype are disappearing, the primary constraint is no longer skill, it is the decision to start. Surviving the AI wave requires moving past the fear of losing your professional identity. Success now depends on your willingness to begin building while the rules are still being written. For decades, the primary scarcity in software engineering was the ability to build. The friction of translating a human idea into functional, bug-free code acted as a permanent brake on innovation. Because execution was so difficult, every project required months of planning and deep technical specialization just to reach a starting point. This friction forced a specific perspective. Engineers began to view the technology itself, the syntax and the mechanics of the build, as the main problem they were hired to solve. But we have reached a point where that mechanical bottleneck is being eliminated. What happens to the software industry when writing code is no longer the hardest part of the job? When the act of building is no longer the primary hurdle, the value of a human engineer moves elsewhere. The focus shifts from the process of creation to the strategy of the solution. In a traditional software development lifecycle, teams debate for weeks to select one idea to build because failure is too costly. AI tools compress mechanical tasks, shrinking the long build phase instantly. This is the great inversion. The logic of production flips. Instead of analyzing 10 ideas, teams can build all 5 potential solutions in 2 weeks. You let real-world performance data determine the winner. Then you scale that specific approach. The engineering mandate is no longer about minimizing the risk of a single build. It is about maximizing the volume of validated solutions. To facilitate this speed, we use an AI dev environment. This is a workspace distinct from production or staging, where engineers can experiment aggressively and generate code at high velocity without risking the existing pipeline. Security is maintained through a strict boundary. No code generated in this environment is promoted to production without a human expert conducting a full review. This creates a new kind of job security. Humans physically write less code, but AI output volume soars, demanding expert reviewers to audit and authorize that work. Accountability remains with the person, not the tool. If you approve and ship a block of code, you own the outcome. There is no "the AI did it" defense. An engineer's worth is now measured by their ability to evaluate, contextualize, and authorize high-velocity work, rather than their ability to generate syntax from scratch. Generic AI models lack the one thing you possess: domain context. You understand the architecture, the specific data models, and the nuances of the customer problems we solve every day. An external model cannot replicate the tribal knowledge or the specific market position of this company. That context is what allows you to direct AI toward a meaningful result. This combination allows us to target the giants, those high-risk, expensive problems in the codebase that have been ignored for years because they were too complex to solve manually. Rather than waiting for requirements to be handed down, engineers act as problem miners, searching the business for these specific points of friction and targeting them with rapid prototypes. By applying AI to these proprietary business problems, the role of an engineer shifts from a builder of tools to a wielder of strategic solutions. This change should not require a long committee approval chain. You should get access to approved AI development tools with a simple service desk request, and begin learning the workflows directly within the environment. The methodology is to pick the largest business problem you can find, then run the smallest possible experiment to prove a solution works. This scales when multiple engineers begin swarming the same target. While one experiment might fail, 20 simultaneous experiments provide the data needed to isolate a working fix. This decentralized approach bypasses institutional inertia. When hundreds of people are validating solutions in parallel, the organization moves faster than any competitor still stuck in a traditional, high-friction planning cycle. You have the choice to be the one who solves the problem or the one who watches it happen. You must think big, act small, and swarm at scale.